In the next few videos, we're going to start taking a look at how we can use MATLAB to do a few of our different types of applications of our iterated intervals. One of which is, if given a density function, we can be able to find the mass and the center of mass of some sort of plate or lamina given that density function. And so remember, to find the mass, you just basically find the double integral of the density function over the given region. To find the center of mass, you take and multiply by the reciprocal of the mass, double integral of x times the density function for the center of mass x, and then for the center of mass for the y coordinate, that's going to be the same thing except you multiply by y. So in this example, we're just going to go ahead. We're going to take a paraboloid, 9 minus x squared minus 2y squared, over this sort of rectangular domain, 0 to 2, 0 to 2. And we're going to go ahead and find both the mass and the center of mass. Define a couple sims variables. Define the function. Right? So it's 9 minus x squared minus 2 times y squared. Okay. And then the mass is going to be really easy. So the mass is going to be equal to the double integral. All right, so I'm just going to do this like we did in the previous example. We're going to have iteration. So we're going to have our first, which is going to be equal to int of f with respect, and it doesn't really matter because it's a rectangular region. So that's going to be x, or let's just say y, comma 0, comma 2. And then our mass is going to be equal to the integral of the first with respect to x from 0 to 2. Right, nice and easy. Now I'm just going to go ahead and execute this so we can see what the mass is. All right, it's just 20. All right, so whatever that unit is, and we're going to go ahead and do some fprintf statements at the end. All right, now let's go ahead and get what the center of mass is. And so the good news is we can just kind of cut and paste the exact same code that we just used. All right, so we're just going to take this right here. Right? I'm going to cut it. All right, so here's our function. And the first is going to be now equal to 1 over the mass times the integral of x times the function, right, from 0 to 2. And then finally, this is now, we're just going to change this to, I'm going to call that x coord. All right, so that's going to be the x coordinate. All right, so literally all I'm doing is I'm just plugging into this formula right here. So we have 1 over mass, which is going to be our constant, or the coefficient out front, and then x times the function. So that's going to be x times the function right here. And we already defined the function to be this, right? Now I'm going to go ahead and just execute that. I'm going to execute both of these so we can see the mass and the center of the mass, right? At least the x coordinate. So we have 20, we have 13/15, and then finally, we can just cut and paste this. And we're just going to change this first to y times f, right? We still have the 1 over mass. So right here, now what we're doing is we're finding y bar, right? So that's 1 over mass times the integral of y times f. And I'm just going to change this to y coord, right? And we can go ahead, just execute that. Now remember, we got 13/15, and I'll show you how to really nicely write this once we're done. All right, so that's going to be our y coordinate. All right, so that's the center of mass of our paraboloid. All right, so we have our mass. So let's fprintf, and we can say the mass of the paraboloid is, and we can just do the same thing where we approximate the 6 decimal places, %.6f /n, and we're going to say comma mass. All right, so that's the mass. We're calling this function, or we're calling that variable mass. And I'm just going to go ahead and execute this. All right, it's going to be 20.00000. We already knew that. Because it's an exact value and because it's a decimal, we could use %d. Right, and notice if you use %d instead, that gives you this. All right, so or you might even be able to use %s as a string, right? And that comes out well as nicely. So what might be helpful for you is to try the 0.6f, and then also try F, or just try D, and then also try S, and see which one gives you the nicest looking answer. In this case, it's going to be D. All right, now I'm going to go ahead and do another fprintf, and I'm going to say the x coordinate of the center of mass is, and I'm just going to try %.6f first, all right, and then /n, right? Make sure that when you do your forward slash, that it's going from top to bottom, all right? If you do this, it's not going to do the return, all right? So make sure you do your forward slash, and I'm going to call comma x coord, all right? And I'm just going to go ahead and execute that, and it's going to tell us the mass of the paraboloid. Oh, I forgot the x in here. So x coord. Right, so it gives us that. Let's try %s. It's not an integer, but maybe %s might give us something. We don't know. All right, and it gives us the precise value, the 13/15. All right, so again, what I'll recommend is try 0.6f. All right, if you try %d, by the way, it's going to round it off to the next integer. That doesn't really help you too much. So in this case, %s, which means string, is going to give you the best answer, right? And then finally, I'm just going to do the exact same thing. I'm just going to change this to a y coordinate, and then I'm going to change this to y coord, right? And again, we're just calling y coord because that's what we defined it as. We already have x coord, so I'm going to go ahead and execute. All right, and there we go. We have the mass, we have the x coordinate and the y coordinate of the center of mass of the paraboloid. Right, so pretty cool that we can utilize MATLAB to do some of these painstaking computations. Okay, and you probably remember before when we did this, we just did really linear sorts of plates. So we did like a plate like that had like a triangular region. We didn't do anything that had a curved region. Right, so pretty cool that we can use MATLAB to be able to do this really quickly for us. All right, in the next video, we're going to take a look at one more application, and then we're going to go from there to look at Jacobians in MATLAB.